Hey everyone, I hope you're all doing well. Today we're going to continue discussing ions and we're going to talk about polyatomic ions. So these are a very special type of ion. In this type of ion, we have multiple atoms, so hence polyatomic, and those multiple atoms have an overall charge. So these multiple atoms are going to be bonded covalently. So remember, in a covalent bond, we have two nonmetals that are sharing electrons. So for instance, you might have a few atoms all bonded together, maybe something like that. And the overall bunch of atoms there will have some sort of charge. So maybe a 2 minus charge or something. So often these polyatomic ions consist of a nonmetal such as phosphorus, which is P, sulfur, which is S, carbon, C, or nitrogen, N, and these are covalently bonded to oxygen atoms. So usually these polyatomic ions will have a negative charge, so -1, -2, -3, except for NH4 plus, which is called ammonium. And this ion has a positive charge. So polyatomic ions are pretty common. If you've ever had a cast, that is made of calcium sulfate. And sulfate, SO4 2-, is the polyatomic ion. So notice again we have sulfur, which is bonded to 4 oxygen atoms, and those are all sharing electrons. And then that overall group of atoms has a -2 charge. And then if you've ever used fertilizer, that typically has nitrogen-containing compounds such as ammonium nitrate. And in this particular compound, we have 2 polyatomic ions. So the first one is ammonium, where nitrogen is bonded to 4 hydrogen atoms, and they're all sharing electrons. And then it has an overall positive charge. And then the second polyatomic ion is called nitrate. And in this one, nitrogen is bonded to 3 oxygen atoms, and they're all covalently bonded, so they're sharing electrons. And then there's an overall negative charge. So in your textbook, there is a chart with different polyatomic ions and their names. And they're also categorized by the main nonmetal that's present in them. So you'll notice we have, I missed hydrogen. We have one ion with hydrogen in it, and it's covalently bonded to oxygen, so they're sharing electrons. But these 2 atoms have an overall charge that's negative. Then we have a few polyatomic ions containing nitrogen, a few that contain chlorine, some that contain carbon, sulfur, and phosphorus, etc. Now, you don't have to memorize all of these names. What I recommend is memorizing the bolded polyatomic ions here and their names. So these are kind of our main polyatomic ions. And once you know their names, it's really easy to figure out the other polyatomic ion names. I also posted some flashcards under the study guides module on Canvas. So there's some online flashcards which go over a wide range of polyatomic ions. And then there's some printable flashcards that you can use as well. And those just contain the highlighted polyatomic ions here, including hydroxide. Now, one thing to notice is that most common polyatomic ions end in ATE. So SO4 2-, that's sulfate. PO4 3 minus is phosphate. NO3 minus is nitrate. Now, if there's a related ion with one less oxygen, then we're going to change the end of the name to ITE, ite. So, for instance, notice that originally we have SO4 2 minus. Well, if we have one less oxygen, SO3 2 minus, we change the end of the name to ite, so it becomes sulfite. Same with phosphate. Originally it has 4 oxygens, but if we remove one of those oxygens, so we have PO3 3 minus, that becomes phosphite. And same with our last one here. Nitrate has 3 oxygens, nitrite has 2. So this is just a naming scheme that chemists came up with to make it a little bit easier to differentiate between certain polyatomic ions. Now, there are a few exceptions to these naming rules. So there is an ion, or a polyatomic ion, where carbon is bonded to nitrogen and it has a negative charge. This is cyanide. And you might have heard of cyanide before. It is a poison. And then the other exception is OH minus, hydroxide. So those end in IDE. Now, what if we add a hydrogen ion to our polyatomic ions? So this is possible. This happens in our bodies, for instance, or if we eat Tums, for example, we might have something like a carbonate ion shown below. And this carbonate ion can attack acid by pulling in some hydrogen ions, which is present in an acid. So if we combine carbonate with a hydrogen, what's really interesting is originally carbonate has a 2 minus charge. And then if we add a hydrogen ion, which has a plus charge, we end up with just a -1 charge on the resulting polyatomic ion. So we've increased the charge to -1 from -2. So the way we can name this new polyatomic ion that we've created, this HCO3 minus, there's 2 different ways. We could call it bicarbonate or hydrogen carbonate. So either one is fine. Now, this can also happen with sulfate. Sulfate can take on a hydrogen ion and become HSO4 minus. So we can call this ion either bisulfate or hydrogen sulfate. Now, the last rule for naming these polyatomic ions, so actually if we go back to our table, you'll notice that in the category for chlorine, we have basically chlorine bonded to a different number of oxygen atoms. So we have ClO4 minus, ClO3 minus, ClO2 minus, and ClO minus. And these are all natural polyatomic ions, so chemists needed a way to kind of name all of these different ions, even though they're very similar. So what they came up with is the following. So if we start with chlorate, which is ClO3 minus, notice that originally chlorate has 3 oxygens. Now if we take away one of those oxygens, so we have ClO2 minus, now the ending becomes chlorite. So that rule is very similar to what we saw before. But what about ClO4 minus or ClO minus? So if you have an extra oxygen, so ClO4 minus, we're going to add a prefix to the name. So instead of chlorate, we have perchlorate. Now, what if we go all the way to the bottom of this list and chlorine's only bonded to one oxygen? We're also going to add a prefix, hypo, but we're still keeping that chlorite name. Okay, so if we go from chlorate to perchlorate, we're just adding a prefix. If we remove an oxygen, we change ate to ite. And if we remove another oxygen, we add the prefix hypo. So again, once you know all of the bolded polyatomic ions, which end in ATE, it's really easy then to figure out the other names of the polyatomic ions just following these rules. But I'm not going to test you too much on these other polyatomic ion names, just the bolded ones, so don't worry too much about these other names. It is good to know, though, because if you go on to general chemistry, you will be tested on those names. Okay, so let's practice writing a formula for a compound that contains a polyatomic ion. So we're going to write the formula for sodium phosphate. Okay. So the first part of this name is a metal, and that is sodium. And we know that this is an ionic compound. So what is the charge on sodium? +1. So it remembers sodium's in group 1A, so its charge is +1 when it is an ion. Now, phosphate, we might need to go back and look at our chart because we just learned about polyatomic ions. So let's go back. Okay, so phosphate is at the bottom. So that is PO4 3-. Okay, so let's write that down. All right, so we have our ions and their charges. So now we just have to balance the charges by adding subscripts. So 3- is a larger charge in terms of magnitude. So how many sodium ions do we need to balance the charge on phosphate? 3. So we're just going to write Na3PO4. So not too bad, very similar to what we've done before. And here are the solution slides for later. Now, again, when you're naming ionic compounds, we always start with the metal followed by the nonmetal. But what if we have a polyatomic ion? So we're still going to write the first ion and its name, and we're not going to change it. So, for instance, we just saw that sodium phosphate has a metal ion to start, and we just named it sodium. Then we're going to write the name of the polyatomic ion second, and we're not going to change it. So this is super easy. Once you know the polyatomic ion names, super easy to name these ionic compounds. Okay, so let's look down at the bottom at some examples. So we have Na2SO4. So we're starting with sodium. Easy enough. And then we just have to identify what SO4 is. Is that sulfate, sulfite? In this instance, SO4 is sulfate. All right. Now, in our second example, we have FePO4. So PO4 is our polyatomic ion. So that's phosphate. And then we have iron, but we have to figure out what the charge is on iron. So we just saw that PO4 has a 3 minus charge. So to balance that out, iron must have a 3 plus charge. So we would add a Roman numeral 3 in parentheses. Now that's only for iron because we know iron can have multiple charges. Sodium has a predictable charge, so we don't have to indicate its charge in Roman numerals. All right, and then the last one, Al2, and then we have CO3 in parentheses, followed by a subscript 3. Okay, so aluminum is another metal ion that always has a predictable charge. So we would just name the metal with no Roman numerals next to it. And then we just have to figure out what our polyatomic ion is. So CO3 is carbonate. Now also notice that here we have multiple carbonate polyatomic ions. Now we've separated the polyatomic ion from the rest of the compound with parentheses, and then we put a subscript 3 next to it. So if you do have multiple polyatomic ions in your compound, you have to put parentheses around it before you indicate how many of them you have. And that's because, let's say we wrote this as Al2CO3 3. It kind of looks like we have 33 oxygens attached to that carbon, which is not possible. So we have to put parentheses around the polyatomic ion only in this instance. In the other two examples, so sodium sulfate and iron 3 phosphate, we only have one polyatomic ion, so we don't have to put parentheses around it. Okay, so let's do a practice problem where we select the correct formula for each of the following names. So let's do the first one together. Aluminum nitrate. Okay, so aluminum is in group 3A, so its charge is 3 plus, and that's one of those metal ions that always has the same charge. And then nitrate. If we look up in our table what nitrate is, it's NO3, and then it has a -1 charge. Okay, so how many nitrate ions do we need to balance the charge on aluminum? 3. Okay, so now if we look at our options, let's see, so we need 3 nitrates and 1 aluminum. So A, we have AlNO3, so that just tells us we have 1 of each ion. Okay, so that's not correct because we know we need 3 nitrate ions. In B, we have Al, and then in parentheses NO, followed by a subscript 3. Okay, so this one also doesn't work because NO is something different from NO3, so we really need to keep that 3 with that oxygen there for NO3. Okay, so that doesn't work. And then our last option, C, we have Al, and then in parentheses, NO3, followed by a subscript 3. Okay, that one seems good. We have 3 nitrates, and the nitrate ion is separated by parentheses, and then we have aluminum. Okay, so I encourage you to try the other 3 on your own, and when you come back, we'll go over them together. Okay, so number 2, we have copper 2 nitrate. So that means we have a copper ion with a 2 plus charge, and we already saw that nitrate, NO3, has a negative charge. Okay, so How many nitrate ions do we need to balance out the charge on copper? 2. Okay, so looking at A, B, and C, which one is correct? So let's look at A. We have one of each. We have one copper ion and one nitrate ion. So that's not correct because we need 2 nitrates. What about B? Yeah, that one is the answer. We have one copper ion and then we have 2 nitrate ions. But let's look at C just to make sure. So in C, we have 2 copper ions. So that's not right. And nitrate has parentheses around it, even though there's only 1 nitrate in this compound. So we wouldn't write that either. So C is not correct. Okay, 3, we have iron 3 hydroxide. So that tells us iron has a 3 plus charge. And if we look up in our polyatomic ion table, hydroxide has a -1 charge. Okay, so which of the following is correct, A, B, or C? So how many hydroxide ions do we need? 3. And that will balance out the charge on iron. So A is not correct because we only have 1 of each ion. B is not correct because we have 3 iron ions and only 1 hydroxide. But C is correct. We have 1 iron ion, and then we have 3 hydroxide ions. And notice hydroxide is in parentheses there. If we had written this as FeOH3, that would tell us that we have 3 hydrogens bonded to oxygen, which is not what's happening here. We actually have 3 OH groups bonded to iron. All right, what about 4, tin 4 hydroxide? So tin has the chemical symbol Sn, and it has a 4 plus charge in this case. And then we already saw OH has a -1 charge. So which option down below is correct? So it would be A, because we need 4 hydroxide ions to balance out the charge on tin. And the only option with 4 hydroxide ions is A. All right. And here are the answers if you need those later. Okay, so we've gone through a lot of naming today, and in the last lecture as well. So if you have an ionic compound, which is a metal and a nonmetal, we're going to name that according to the metal, and then we'll take the first syllable of the nonmetal and add IDE. However, there are a few other options or a few other types of compounds that can occur. So remember, the metal could have variable charge. So let's say we have a metal with only one type of charge. Then we're just going to use the name of the element. Or you could also have the polyatomic ion ammonium. That could also come first. Now let's say you have a metal that forms one or more, more than one positive ion. Then we're going to follow the metal name with a Roman numeral. And that's going to be equal to the charge on the metal. Now, for the second part of our compound, we might have a nonmetal, and we're just going to, again, use the first syllable of the element followed by IDE. However, we just saw you could also have a polyatomic ion, which is negatively charged typically. So then we would just use the name of the polyatomic ion. Okay, so In a future video, we're going to talk about molecular compounds, or we also call those covalent compounds. And that's where two nonmetals share electrons. So we'll talk about how to name that in the future. All right, so if you want some extra practice for naming ionic compounds, I have a worksheet up on Canvas under Modules Week 5, and the answer key is also available there. So definitely work through that worksheet if you're at all confused about how to name compounds. Hopefully that will help you kind of see some of the patterns and get a feel for it. Also, feel free to consult the chart with the polyatomic ion names to start. And then as you go on, you'll probably start to memorize them. But again, I have flashcards posted for memorizing polyatomic ion names. So definitely work through that as well. And next time, we're going to talk about equations that contain polyatomic ions. So how do we balance those equations? How do we figure out what products form from two compounds that have polyatomic ions? So we'll talk about all of that next time.